Good afternoon and welcome to the first Pennsylvania Recycling Market Center Technology Tuesday webinar. I'm Felix Hottenstein, the Sales Director of MSS, and I will present to you advanced optical sorting technologies for MRFs. First, a quick overview of our company and our group of companies. As you can see, we belong to the CP group. And the CP group belongs to the IMS family of companies, which are all owned by the Davis family in San Diego, California. The IMS group has two branches. One of them is operations, where we operate a single stream MRFs, several electronics recycling facilities, etc. The second part is the manufacturing branch, which includes the following 5 companies. CP Manufacturing, which designs and builds complete turnkey processing systems for recyclable materials, municipal solid waste, etc. We have Cross Manufacturing, which specializes in equipment for construction and demolition waste. MSS is the optical sorting division. IPS is a full-scale baler division. We manufacture everything from small vertical balers to large 2-ram balers. And we have our 5th company, which is Advanced MRF, is our controls and automation division. Before going into the optical sorting, I would like to briefly touch about some other more conventional MRF separation equipment, so you can see a little more on how the optical sorters tie in to the more conventional sorting equipment. I'll talk briefly and show some pictures about sizing equipment, which includes trommels and disc screens. Talk about mechanical disc screen technology, which we use to sort OCC, newspaper, mixed paper, and to break glass. I'll give a quick overview on air classification equipment and where we use it, as well as conventional metal separation technology, which includes magnets and eddy current separator. In regard to the sizing equipment, just a few pictures to visualize what we use sizing equipment for. In the upper left, you can see a trommel that separates out glass fines, let's say maybe a 3/8 inch or 10 millimeter minus from the overs. We use much larger trommels to size municipal solid waste and commercial industrial waste, which you see on the bottom left. And we use elliptical disc screens that you see on the right to size and separate out large OCC. The mechanical disc screens I mentioned, as you just saw, and here's another picture of 2 machines in parallel in the upper left. We use the disc screens to sort large cardboard out from all the newspaper and all the containers. Bottom left, you see a disc screen that breaks and screens out any glass. On the upper right, you can see an inclined deck disc screen, which we use in this particular picture to sort out newspaper from other paper grades, lower paper grades, and containers. And on the bottom right, you see a unit that will screen out mixed paper from containers. In regard to air classification equipment, we mostly use it for 2 types of applications. One of them is, and you can see a picture on the upper left, is sorting single sheets of fiber from containers, so that the containers are even better prepared to go through the container line where the metals and the plastics are being sorted. This, besides improving the efficiency of the sorting equipment for the plastics and the metals, also reduces the amount of fiber that would go into the residue and instead is recovered back into the mixed paper stream. On the bottom right, you see an air classification system that we use to separate fines and light materials from broken glass. And we have been using these for many, many years and installed dozens of those. They're quite simple to operate and work very well. Quick overview on magnetic separation. We use different types of magnets depending on the application, the volume, etc. The picture you see here shows 2 overband magnets that are arranged at a 90-degree angle. In larger MRFs with higher throughputs, we have started using drum magnets, which have a big advantage in low maintenance and very efficient separation. For sorting the aluminum cans in MRFs and municipal waste facilities, we normally use eddy-current separators. And if you've seen those, you know how they work. But in this particular picture, you have a fast-moving belt running from the upper right to the lower left. And inside the head pulley is a fast-spinning rotor that induces eddy currents into the aluminum cans. And because they're non-ferrous, they react to them. And what happens is that the aluminum cans jump across that splitter that you see, that get repelled by the high-speed rotor inside the head pulley, and get therefore separated from the mainstream of materials, plastics, that just fall into the chute that you see there. That kind of gives you an overview a little bit on conventional equipment, conventional sorting and processing equipment, mostly mechanical, that is used in MRFs. And now I'm going to go into the optical sorters that we use, that we manufacture, and I'm going to give you a quick overview on the history, how optical sorting works, and then I'm going to go through a list of different types of optical sorters that we use for different applications, so you kind of get an overview of in what situation we would use certain optical sorters. MSS was founded in 1974 by Gary Kenny. In the early years, they specialized on metal detectors, but in 1989, the first optical plastics sorting system was installed, and since then we're probably now in the 5th or 6th generation of these optical sorting systems. 1993-94, we developed technology to remove ceramics from broken glass and ColorSort the glass. In 1998, we installed the first high-speed optical paper sorting system, which was the first one in the world. And in 2006, we installed the first optical sorting equipment in an electronic scrap sorting facility. MSS has been part of the CP group since 2003. Just real quick, when we talk about optical sorting, a little bit of physics here. You can see the bandwidth of the overall electromagnetic spectrum going from the shortwave, cosmic and gamma rays to the long wave heat and radio waves. And the optical sorting happens really only in a very, very small part of the spectrum. The visible, obviously, as you know and you're all familiar with, goes from the longer blue wavelengths to the shorter red ones with the whole rainbow of colors in between. To the left of it, we have the ultraviolet spectrum, which we use every once in a while, and to the right of it, we have the infrared spectrum, which we use a lot in optical sorting for plastics mostly. So how does it work? When you look at near-infrared sorting, which is used to distinguish and identify different types of plastics and polymers, which is a lot of things that we do in the MRFs and the municipal solid waste processing facilities. I compare it somewhat to the visible light, where if you have a camera and a detector, it normally measures absorption in the red, green, and blue, the RGB wavelengths. So if something is red, it absorbs green wavelengths and therefore looks red to the human eye. And in the near infrared, it works very, very similar in that you illuminate a material and certain wavelengths are reflected depending on the absorption of the molecules that you're looking at. And the wavelengths are in the near infrared, so the human beings can't see it, but the principle behind it is just the exact same as in the visible. And in the near infrared, we just use a lot more different wavelengths. As I mentioned, in the visible, you use red, green, and blue normally. But in the near infrared, we use a lot of them. Depending on what application, could be dozens of them. Here, for example, you see a spectrum of different plastics, nylon 6,6, PET, and polypropylene in the spectrum of 1350 to 1800 nanometers. And depending on what wavelength you look at, you can see different absorptions for different polymers. And if you compare those, and you compare them over a whole spectrum of wavelengths, you can tell the different plastics apart from each other, just like you can tell different colors a whole rainbow of colors apart from each other. It's exactly the same principle, but instead of just red, green, and blue, we look at many, many more wavelengths at the same time. How we do it in an actual machine, we have, in most of the time, pretty much all the applications, we have a fast-moving conveyor where the material is spread out over the whole machine width. We illuminate the material or the belt with, most of the time, halogen lights, and which is the beige bar shown in this diagram. The light, which is shown in yellow, is emitted and focused on a narrow band on the conveyor, maybe an inch or two wide, and focused so that it's very, very bright in that particular spot. And we have a scanner that, just like at your supermarket, if you've seen those little red scanners, like laser scanners, it's very, very similar, just is in at a different wavelengths, the near infrared versus the little red laser, but it scans the whole width of the conveyor in a very similar manner, and it obviously then the data that is detected, the light that is reflected from the material, is analyzed by very fast computers, and the computers then determine what the material is, where it is on the belt, and depending on how the operator set the materials, the ones that are supposed to be sorted out, it will activate the air jets to be sorted out. Just for a visual, so you can see what halogen lights look like. The ones we use, you see on the center towards the right, you see the halogen lights with a very strong, very nice mirror reflector to bundle the light and focus it as strong as possible on the belt. And you can also see the lenses, the lens blocks that we use to focus the light onto the detectors. And so we normally have 2 rows of halogen lights to avoid glare and to increase the intensity to look at. And you can see that here on the left, if we have different light source and sensor arrangement, just depending on the application. On the left, you can see what we call reflectance, where we measure the material of a belt. So we have 2 light sources, and the light that's reflected goes to the center where the sensor array sits. For different applications, for example glass, sorting of glass, we have to look through the material, and we use a transmission arrangement where the light source is on the other side of the sensor array and the light goes through the bottles or the material. We also have a sensor arrangement that is a combination of both, where we have opaque items, the light is reflected from the light source, goes into the sensor array, and we have, for transparent objects, the light goes through the object, hits a reflector, and the light is reflected back through the object into the sensor. And this mostly we use to do fairly difficult applications for color sorting of PET bottles. For example, very light blue from clear bottles can be sorted very effectively with this setup. Furthermore, we can add a metal detector into the conveyor, which allows us to measure and sort out any residual metals that might not have been recovered by the magnet or by the eddy current. And the air jets are, the computers link the information from the optical sensor and the metal detector and combine it, and then if the air jets are supposed to eject metals, they will obviously be targeted appropriately and sorted out. In regard to what is mechanically exiting an optical sorter, we are able to either have one air ejection array which generates 2 outputs from one input, or as shown here, we can also generate 3 outputs from one input by using 2 air ejection arrays, where we have an eject 1, which is the light green, we have an eject 2, which is the darker green teal kind of color, and then we have the pass-through material, which is the orange material. So this gives you kind of an overview of how near-infrared technology works on the detection side, what kind of sensor arrangements we have, and how physically the materials are separated with the air. Now I'm going to go through the different types of machinery we have, so you can kind of see what machinery is used in what application. The first one I will discuss is our Aladdin optical sorter, which we use in MRFs and also plastic recyclers converters facility. You see a picture here with the long conveyor. The sensor sits on top of the conveyor towards the end. You can see the air conditioning unit on top there as well, and the catcher hood at the end that collects the materials that are coming out. We use the Aladdins in MRFs to sort PET, HDP natural, HDP color, number 3 through 7 plastics, as well as beverage cartons. At the plastics recyclers, most of them that receive PET will sort out PET by color, green, blue, brown, red, yellow, whatever you have, and of course, most importantly, remove any non-PET contamination, and the most important one of those would be PVC. We also can sort out opaque PET. For example, as you may know, some of the ketchup bottles or some of the shampoo bottles are actually PET, but they're opaque, and they have fillers and colorants in there that the recyclers don't really like, so they have to be removed. A few more pictures of how our optical sorters can be arranged in a facility. This just shows a few Aladdin units. This one in a MRF, located at MRF, shows 2 units in parallel to handle high volumes. This one shows 2 of them in series, which is what we need if we want to sort more than 2 or 3 or 4 commodities out of the stream. We need multiple machines in series. These 2 machines are arranged at a 90-degree angle. Sometimes there's not all that much space in a facility, and we have to be creative with how we arrange the machines, and even more in this particular picture where the machines are situated on top of each other, and the material runs through the first one from the upper left over to the right. The material that passes through the first machine falls directly onto the tail of the second one and runs backwards towards the infeed again and is sorted a second time over there. Our Sapphire FiberSort machinery is the smaller brother of the Aladdin units. And you hear a rendering of a system with 2 Sapphire units in series here. The Sapphire we use in MRFs to sort HDP, number 3 through 7 plastics, beverage cartons. These first 3 are on the container line, and we can use them in other areas in the MRF as well, for example to remove non-paper contaminants on a mixed paper line, such as plastics, trash, etc. We also use the Sapphire in MSW, RDF, CNI, C&D facilities if we want to sort out just different types of materials such as fiber, all plastics, or PVC. The FiberSort, again, as the smaller version of an Aladdin, if you will, we use in the MRFs to sort out non-paper contaminants. We use it to sort out brown OCC and non-plastic contaminants on a container stream. At a paper recycle, we would use it to remove non-fiber contaminants and brown OCC, and in the C&D side, we would use it to sort out wood. Our MultiWave unit is a very high speed, very high capacity paper sorting unit. We can build it up to 96 inches wide, and we can run it up to 1200 feet per minute or 5 meters per second. And we use it in paper recycling facilities as well as very high volume MRFs. It can sort all kinds of different paper grades, and you can just see a few over there. On the right, newspaper, mixed paper magazines, colored paper, brown cardboard, printed cardboard, and of course non-fiber items such as plastics, metals, textiles, and residue. We also have a unit we use specifically for office paper sorting is our paper sort unit. Somewhat similar to the MultiWave, but it does not have the near-infrared capability to sort the different types of material. This one only sorts by color and color pattern. And so for office paper applications, we use it to sort news from mixed paper, brown from printed cardboard, and white paper from non-white paper. This unit, as the MultiWave, runs at the super high speed of up to 1200 feet per minute. Going to the next commodity in a MRF, we can use our glass and ceramic sort unit to remove contaminants from a glass stream, such as ceramic stones, porcelains, and metals. And of course, as you see in the picture below, we can generate a clean green glass, amber glass, and flint glass. Just to give you a little more visual on what these pieces look like, you can see encircled in the upper left a small piece of ceramic that we need to remove. Ceramic has to be removed very, very efficiently in order for the mills to accept the glass. And you can see the different types of colors. You know, we have green, olive, yellow, blue, brown, and so depending on your application and your markets, your geographical area, one or the other colors can be sorted if required. Our optical sorters are touchscreen driven. They use a very intuitive user interface. In the upper left, you can see the screenshot of the main screen that shows the current status of the optical sorter, the input-output controls, external controls, etc. Some temperature monitoring inside. It shows what is being sorted at this particular point, etc. At the lower left, you can see some different sort configuration, like a recipe. So depending on your material, or you may have different customers or different sort setups, you can press the buttons on these different recipes and select between two completely different sort setups with just one click of the finger. Behind each of these recipes, at the bottom right, you see what we call a sort configuration, and you see the list of all the different types of materials that have been programmed into the library of the optical sorter. And then all you do is select which ones of these commodities you would like to sort, if you would like to sort it up or down or into the pass, and therefore, you know, with one click of the finger, the machine will change its sort configuration if you would like to do that. Also, of course, because this is computer controlled, we have remote access to it over various different ways if required. We can use PC Anywhere software through a modem, Ethernet connection. We can do Windows Remote Desktop. There's other software solutions that we use to access the machines remotely, so we can assist the customer with troubleshooting, with additional new sort setups. For example, in a PET recycling facility, you all of a sudden have a new color that you have to train in, so we can use the remote access to sort all these, to set up all these sort setups for the customers. Now, this presentation was mostly about optical sorting in MRFs. I would like to show you a couple other applications where we use even different type of technology. In the upper left here, we have our new high resolution, much higher resolution near infrared optical sorter that we use for granulated and shredded materials. So for example, on the electronic scrap recycling, we can sort out circuit boards, copper, wires, etc. We can sort different types of plastics like ABS, high impact polystyrene. And on the plastics recyclers, we can use the same machinery for to sort bottles and flakes, again especially the flakes for the granulated or shredded materials by color and by type of plastic. The picture at the lower right is our Elvis unit, which is our high resolution camera sorting systems for really small particles to sort by color, and the picture on the upper left is our new Cirrus unit that has the color capability, but most importantly has the near infrared detection as well. So I hope I was able to give you a little bit of an overview of the optical sorters that we use in MRFs, where they go in the MRFs behind the conventional mechanical sorting systems. And if you have any questions, please don't hesitate to call or email me. Thank you so much.